Myself, I'm Vamsi Krishna, and me and our team members have prepared this project, and we have tried to analyze the effects of soccer matches on the inflow of flights to the match locations. For this, we have chosen UEFA Champions League, where there are home teams and away teams, and there are flights coming from away teams to home teams. And we want to analyze, because of the soccer matches, what is the effect on the inflow of the flights from the away team. Here you can see the task list, the task description and due date and responsibility of each one. And then here we have shown the introduction of our project, where we showed what we will be solving as part of this project, and we have given here the references where we will be taking the football data from an API football, and then uh, we have taken aeroplane data from Rapid API, and we have some requirements regarding how you should run this code. For that, you need to install some basic Python packages like pandas and numpy. We will discuss more about this. If those basic packages are not available in this, you can install through pip install method, and you have to sign up for the Rapid API to find your API key, and then paste it in the code below for the code to run smoothly. So here we'll be explaining the code a little bit. In this project, we need to import these many Python packages, and if you find yourself not having these libraries or when you're importing these libraries you are finding an import error, we suggest you install the missing libraries through pip install method. And from here you can see, you can paste your personalized Rapid API key that you get from the website here to proceed further. And then here we get a list of countries from the API that is given here, and then we got the data in the form of a dictionary. And since we have included only codes, since this is a very big project and the code blocks are very big, uh, uh, we thought it would be better to include only those blocks of code which require explaining. To explain the code further, to explain each and every line of block of code, I am shifting to my IPVNB notebook. So here is the whole code that I want to explain. So as I discussed, here is the countries data that is in dictionaries, and then here is the data of leagues that we got in the same way. And this is the whole data of UEFA Champions League, and what is the idea of the Champions League, and what years it happened. And for this project, we have chosen 2020 Champions League, and from that Champions League, we got all the dictionaries. We got the data in the form of a dictionary, and from that dictionary, we have converted the dictionary into a data frame, only extracting the required columns. We have applied a lambda function and chosen only the required columns like fixture, league, and teams from this, and we got date, city, time zone, league name, everything. And we have converted the datetime to a standard datetime format, and then we have sorted them along datetime format, and then we have further added cities, and we saw that there are cities and country columns missing in the preceding data frame. So we added those columns also, taking another API file, API key, and then we have extracted the required columns from the another API, and then added the required columns further. So this is what we get. Finally, here we have made an assumption. This is what the required columns that we got. These are the columns of home teams and away teams, home team country and the capacity of the home team stadium, and then away team country, everything. And then from here you can see the number of rows are 178. We have observed that there are some places where the home team city is different from the place where the match is held. So we have excluded those rows, and we have only kept those rows where the home team city is same as the city where the match is held. So from there we can see that we have excluded almost like 15 rows. So we'll only be working with these 160 rows further. Next, to flight data, we'll get the data of the flight from the airport. For this, we have chosen Flight Radar API, Flight Radar from Rapid API. Yeah, in the same process that I described earlier, we have got the airport data frame where we'll get the name of the airport, IATU code, ICU code, the city where the airport is, latitude, longitude, size, and everything. And from this, we took only the required columns using ILOC method, and then we have also made another assumption that wherever the match is held, there are some situations where the airport is not present there. So we have made the assumption that people will be coming to that place where the match is held from the biggest airport in that country. So we have grouped the country by the size of the airport, and then we have took the airport with the maximum the biggest one with the maximum capacity, and then updated the country with the updated the city with this airport code. And the final data that we have got is uh, this this is the airports of the cities, the airport city. Here you can see some missing values. We'll deal with those in the later sections. We have updated them with the latitude and longitudes also, and then uh, we dropped NA. We removed those rows where there are no values available. So we have essentially come from 163 rows to 149 rows. And then here we have an important note to make. Here we could not find any free online sources that provide any necessary data to that is required to process this further. That is the average number of flights and the number of flights on any given day. For it is only available from only the last year. Only the people who have the enterprise key only have the historical data to the last 10 years. So we had an employee who has an enterprise key, and we asked him to give the particular data after sending this data, and he was generous enough to provide us this data. So we trust with that data, and then so we merged that data with this column that is there. So we request you to download this one and this data from the GitHub repository we provided. You can see it here, and then run this code further. You can this line of code will read the CSV into data frame. Here you can see the average number of flights and the number of flights Air France, Lufthansa, and British Airways. So here also we have taken the top 3 airlines only. Here we'll proceed further to the analysis of this data frame. Here we are analyzing the display of number of flights between away and home countries on a match day. So we are displaying number of flights between the away and home countries on a match day. Here you can see when there is a match in the home team, which is Club Brugge, and there are flights coming, there are people coming from the away teams like Lazio, Borussia, Zenit. We have taken the average daily flights which would normally be from Lazio and Club Brugge, and we have compared those average number of flights with the flights that are flown because of the match. You can see there is an increase here. Here there is a slight decrease, but here you can still see the increase here. So for the whole data, this is just a single example of a single home team. For all the home teams, we created a correlation matrix, and we can see that if the average number of flights are increasing, there is a 93% of correlation for the number of flights also increasing by a big margin. So here we'll proceed further to the second graph, where on different days for a home team, number of flights of different airlines are compared. As we discussed, we took 3 top airlines and we compared those top airlines number of flights because of the matches, how those affected because of the matches. Here we can see the average flights, average daily flights. You can see in the dotted blue line, and in the normal blue line you can see the average number of flights on that particular day, and how these and what is the share of the number of flights during the match day for the top three airlines. You can see that Air France is here, Lufthansa is here, British Airways is here, and we cannot visually see any correlation between these three airlines. As you can see, there is not Air France here, Air France here, and Lufthansa here. So it is not easy to make any conclusions from this graph. And we can see we have also made a heat map for the further. So as discussed in graph 1, we made a correlation matrix, and we saw that we got a 93%, and this is a visual representation of that 93% correlation. And you can see that average flights by home team. You can see that Borussia Borussia has highest number of average flights that are coming to that home team. So this is the bar chart of that, and then you can see, and finally we're comparing finally we have the heat map of different airlines that are there. We can see the correlation between Air France and British Airways of 0.048. That means very slight, 4.8% of 4.8% of correlation is there between Air France and British Airways, Lufthansa. But still, seeing these numbers, there is not any correlation between the airlines, as we saw between average daily flights and average flights and number of flights. Here we cannot see any correlation between Air France, Lufthansa. So here we can see in this we have a map. Here, if you run this line of code, you'll be asked to choose your home country. If you choose your home country as Liverpool, you'll get this graph. This is the graph where the home team is Liverpool, the away team is Liverpool. From here, the person is going to Madrid when the match is happening in Madrid. So if you hover over the lines, you can see the number of flights, and here also same. So if you hover over the location marker, you can see where this thing is going, where the match is being held. So it is Rome. So if you come back to the second map, we have consolidated everything. We have consolidated every match location and number of matches held and flight routes between the match locations in a single HTML file, and which will be saved to the directory that you are running this code from. And you can see this here. These are all the matches that are being held in the UEFA Champions League 2020, and you can see the markers. If you press the markers, you can see the airport code here, and you can see the color gradient of the small circles. If you press on the circles, you can see that there are this is the highest where the matches held, which is 4 matches. If you can see, this is the least color gradient, which is 2 matches. So that's how and if you hover over if you can see the lines, and there are also number of flights. You can see the thickness of the lines is changing, and the number of thickness of the lines describes the number of flights that are being flown from one country, one city to another city. Now coming to the results part. So these are the results from analysis. As we already described, we can see average daily flights here, and the flights from the different cities here, and flights for Real Madrid. This is the flights for Real Madrid, and we have already discussed about the Air France and Lufthansa and this thing. And then we can see that positive correlation is there, and we can see that Borussia is the average flights from home team is the highest here, and we can also see that there isn't any correlation between the airlines, but we can see the correlation between average flights and number of flights. This is our project. Thank you.